problem, we are given some key features of a quadratic and asked to determine which of the following are true. Let's take a look at these key features and see what information we can get out of them, and then look at our choices. Our first feature is that it has a y-intercept at 0, 0. So from this, I can also conclude that c must equal 0 in my equation. All right, we're told a second difference of 2. That has a connection to a in my equation. I know that a is equal to half of the second difference. So for this problem, a is equal to 1/2 of 2, which is 1. All right, so I get a equals 1 from the second difference of 2. My next piece of information is that the minimum is at -1, -1. This reveals the vertex as well as the axis of symmetry. So my axis of symmetry must be x equals -1. Let's take a look at our choices to see what we can immediately know is true. So here I see a equals 1. That is true. So that is one of our selections. Let's look at the next choice. Axis of symmetry is y equals -1. I can see that one right away is false because it must be x equals. Every parabola will have an axis of symmetry that is vertical. So this is false because it should be x equals -1. All right, let's take a look at our next equation, y equals x squared plus 2x. I'm not exactly sure about that one. It seems to fit because a is 1 and c is 0. But I'm really kind of questioning this one for b. I'm not really sure about that one. So we'll come back to it. Okay, and then we have our graph. So let's see on our graph. An axis of symmetry at x equals -1. That seems to be good. A vertex at -1, -1. That seems to be good. A y-intercept at 0. That seems to be good. And an a value of 1. So if I go from my vertex to the next point on the graph, I went up 1 over 1. So an a value of 1 looks good. So I would say that this is true. Now let's go to our table. We know that the y-intercept must be 0. That appears to be the case for 0, 0. Second difference of 2. So let's go ahead and find our first difference. So that would be +1, +3, +5. Second difference, +2. That appears to work. That looks good. Okay, it says a minimum at -1, -1. So that's proposing that this point right here is the vertex. Well, if that's true, then my next point above would be -2, 0, because I would need that symmetry around that point -1, -1. Let's see if that works for our first and second difference. So from 0 to -1 would be -1. And then -1 to +1 for my second difference is +2. That appears to work. So it looks like this table is true. So the table is true, a equals 1 is true, the axis of symmetry is false, we're still not sure about that equation, and our graph is true. To figure out if this equation is accurate, we could graph it in Desmos to see if it matched the graph. We could also insert our table into Desmos and run the regression, and we will find that that is our equation. So in Desmos, I would go to my table. I would do x1 and y1 and enter this table that I determined was true. And then I would do y1 tilde a x1 squared plus b x1 plus c. And I would find that this is the equation.